just...
Thank you. I don't want to mess up your stuff.
Good morning, everybody. Welcome to Central Pennsylvania GIS Day 2015. My name is Nicole Unst, and I'm GIS faculty here at Houck. And we are really excited this year to have wonderful programming to bring to you for GIS Day. This GIS Day is our 7th GIS Day. We began this event in 2009, so we are really happy that this is an event that continues to grow every year. And this year we're doing something a little bit different with having a couple of keynote speakers to bring to you, to bring a national perspective on geospatial technology. So without further ado, I'd like to introduce our first keynote speaker, Michael Houck, from the American Society for Photogrammetry and Remote Sensing, which is a mouthful to say. Michael is the executive director of this organization, and he's going to be sharing with you his thoughts on the past, present, and future of GIS and geospatial technology. So join me in welcoming Michael.
Thank you, Nicole. Thank you. Hello. I'm happy to be here. I hope you are as well. Well, this was advancing. Vince, does it turn off?
There is an on-off switch on the side.
Pointed at the projector.
Yeah, it's going to be the laptop.
Let's try it again. It worked in testing, I swear it did.
It really did.
But I'm going to guess that if any of you have worked with GIS systems and done demonstrations, like taught in a classroom or worked in front of a customer, that something like this has happened to you too. Raise your hands. Yeah, sorry. And you probably did test in advance as well. But you know what? If this doesn't work, that's all right. We'll go... Nope, that's all right. I'll just use...
You can either use the left click or right arrow.
All right. So first GIS Day was about 17 years ago, 16, 17 years ago. Who, is there anybody here who's younger or who was not here in 1999? Anybody? There may be online somebody of that age. And thank you to Esri, who started that, and I believe is a sponsor for this event today. They're also a member of ASPRS, and we're very happy about that. So 1999, first GIS Day, here we are 17 years later. And I'd like to bring to your attention this quote by Jack Dangermond. The application of GIS is limited only by the imagination of those who use it. So today, I'm going to talk a lot about imagination. I'm going to stress your imagination. And some of this may be a little far out there for some of you. I don't know, especially as I get into the end of it, because I'm not going to be constrained by conventional thinking today, and you won't be either. So first, though, a little bit about me, and then I'd like to learn a little bit about you, so I can tailor this conversation. For myself, my first GIS, actually, I think it was around 88, not 87. I actually built a GIS which was for managing a bunch of wells, tens of thousands of wells underneath the city and on the port of Long Beach. And back in those days, the computer was a big microcomputer in a room with a raised floor. And the database was Ingress. Anybody here ever use Ingress? It's an early relational database, one of the originals. And this was actually a pretty forward-thinking program, because not only did it manage things on the surface, but it also managed things in the subsurface. It was a three-dimensional GIS. And that's just a taste, for sure, of where we're going. But realize that we were doing that 20 years ago. But I think more and more we're going to get into the third dimension and the fourth dimension of time, and maybe other dimensions in GIS as the future unfolds before us. This is my organization, ASPRS. It's been around 81 years. And we are still always trying to advance both our core fields of photogrammetry, but also explore new areas such as UASs and new technologies. And of course, GIS is one of those that we adopted some years ago. If you want to learn more about us, you can go to our website. This is American Society of Plastic and Reconstructive Surgeons. Sorry. And I am so glad that you didn't need this slide, because I want to make this interactive and fun, so laughing is fine. This is really our website. If you want to learn more about us, go here. Now, back to this slide. I'm sure people recognize Roger Tomlinson, the father of GIS, often called that. And this quote, you can read it, but he was speaking to the Canadian government at the time when he wrote this, and this is in the 60s, and he was saying to them, imagine that you're a farmer. Do we have any farmers in the room? Or anybody who grew up on a farm? Yeah? Good. Yeah. And he said, imagine you're a farmer, but you just inherited a farm. And so you don't know anything about your farm. You don't know where the water is. You don't know about the soil. You don't even know its geographic extent. But you have to make decisions about it. Do any of you guys in this room have to make decisions every day about things you don't know anything about? Yeah, I do that all the time. So I'm always looking for information. And so this was the origin, the genesis, really, of the first GIS, was exactly that, and this man. Although, this will get more complicated as I talk today. So, the past. We're going to talk about past, present, future, geography, information systems, as a way to think about GIS, past, present, and future. So, I'm sure everybody's heard this saying. I love this one. If you control the past, you can control the future. And how do you control the past? By controlling the present. Because what we say today in the present used to be the case, we claim it used to be the case, then we can use that to argue for the future. 1984. I was a kid when I read 1984, the book, and then when 1984 happened, the world didn't seem like that. But if you think about today's world, it's looking more and more like 1984. It just took longer for that to happen. And of course, the future, this is very appropriate. We're in a theater. So this is a great saying. Don't make any forecasts about the future. You're pretty likely to be wrong. Nonetheless, I'm going to tell you a bunch of wrong stuff here in a few minutes. All right, GIS past. One could argue that this is an example of an early GIS. It's a map, yes, but it's also, so it lays out geography, but it's also a system, because what's kind of hard to see, but if you look very, very carefully, can you see these lines on here like that? These lines are lines where this map was stitched together. It's actually a bunch of independent maps that have all been put together into a large map. And it was designed this way, as a system, and it conveys information. Just didn't have a computer. Of course, this is the GIS that I'm sure you all know today. That's pretty much what you're used to working with. This is maybe the GIS of tomorrow. Now, I'm not saying that a UAS is a component of the GIS system where basically you collect data with it and you use it to input into something like that. I'm not saying that. I'm saying that is the GIS. That might be actually how you get your information, see your information with a mobile handset, and do analysis, the kind of analysis you do right now. You might be able to actually do in the field with a system in real time. Just think about that. So now let's talk about geography, information, and systems. Geography, to describe, literally, this is just to describe, picture, write about the Earth. Not that complicated a notion. And of course, geography over time has become culturally different sorts of things. And historically, it's been about physical places on the planet. But as we'll see, we go into the future and the present, even with the internet, geography is developing new definitions or new expressions. Information, to give form to the mind, basically to structure something about the world or some idea, some concept, and to frame it so that in principle we understand it. And system. And this is the day of systems, as you all know. It's basically this whole compound parts, and a system is about what's inside the system, what's outside the system, how things operate within the system, and how the system operates with what's outside that system, and how systems interoperate. I mean, we all kind of intuitively know about systems. So I give you these definitions because as I talk about GIS, past, present, and future, just think about, before you argue, you say, well, no, wait a minute, that's not a GIS. Think about the definition of the words that go into GIS. Past. I mean, we all know this. Information isn't necessarily knowledge. I mean, just because you know something doesn't mean that you can use it. It's not really usable knowledge. Not necessarily. But let's look at the past. I'm going to argue that this was the first GIS. Anybody want to disagree with me? Would everybody who's able please stand up? I'm serious. Would you please just stand up? Yeah, great. Thank you. You're a great crowd. I appreciate that. Now, if you can, take one just tiny small step to the right. Right? And then take one tiny small step back to the left. And then you're free to sit down. Thank you very much for that. All right. So you just traversed some geography. And there's a system up there called your brain and your body that enabled you to traverse that geography. And obviously there was some information involved because I asked you to move to the right and to move to the left, and you did it. So arguably, this is the first GIS, the brain, the nervous system and the body and everything connected to it. Yeah, just think about that. This is the first map, one of the very first maps ever known. It's 25,000 years old. 25,000 years ago, human beings were making maps. This happens to be from the Czech Republic. There's no computer here. It's not even necessarily a system. We don't know much about it, but it's just carved on an elephant tusk, or not an elephant, but a big tusk. This is arguably a GIS. What are they mapping here? I mean, it's the stars, the rise of the sun. But it's definitely a system. You can pretty much see that. And it's absolutely about geography, and they're trying to get some information from it. What they use it for, I'm not quite so sure, but anyway, it's circa 3000 BC. Since then, things have evolved further. This is from the Song Dynasty, around 1000 AD. And the top left is basically this little fish that's magnetized, and so it turns the lodestone, basically the origins of the compass, which they turned into a compass in the Song Dynasty, and that's representative of that. And they also created maps. But this is not just a regular map. Obviously, it has places on it and geography on it, but you see all these vertical and horizontal lines on there? Taxation boundaries. So I'll argue this is early GIS. No computer yet. But now, the period of the 1730s, thereabouts, England as this ocean-going nation, Britannia rules the seas, had tools that they used. They had maps, and they had the compass which they could carry on board ships, and this is all from about the same period. And then, are any of you guys surveyors here? Anybody survey or know how to survey? When you survey, sometimes you'll take a shot. And this goes back, way back, to something called the Jacob staff, which is basically a way of measuring how far off the horizon a celestial object is. And if you know that, then you can tell how far south or north you are when you're at sea. The problem is they couldn't really tell how far east or west they were until the clock, the chronometer, became something that they could use at sea. They had clocks before that, but they had big long pendulums, and you can imagine the problem with a pendulum on a ship, which is swaying to and fro. But these clocks, they didn't have that problem. And so this was a major development in the history of GIS. A clock, as you know, is an analog computer. So now, don't we have it all there? We've got geography, we've got information, we've got systems, we even have a computer involved. Now, back to the invention of GIS. Any Harvard graduates here? Anybody go to Harvard? No? Okay, good. We're going to poke at Harvard. They might be on the broadcast though. But anyway, Harvard, the invention of GIS. Innovation that arose at Harvard University in the 60s, they say. That's close to being correct, because actually, this, Mr. Tomlinson again, that's the origin of GIS, at least the first one that was deployed, and it was a little bit earlier. 1967 is when a film was made, but this project started in the 60s, and this is the Canada GIS. There's a great YouTube that you can watch. It's called Data for Decision, and it's in 3 parts on YouTube. It's easy to find. The Geographic Information System of the Directorate of Regional Planning, Information Systems for the Canada Land Inventory. That's, as far as I know, the first commercial GIS. And Tomlinson also wrote the paper where it was GIS was first described. So now we've got real computers involved. Go a little bit forward to that. Everybody recognizes this probably as a representation of GPS, Global Positioning System, satellites circling the Earth. But you know the amazing thing, if you think about it, it didn't go operational until 1995. Who doesn't just automatically today just assume the existence of GPS? I mean, you know, your cell phone uses GPS. In fact, speaking of which, GPS got integrated into the cellular system. FCC mandated it, actually. And now the cell phones talk to the GPS satellites, and they also talk to the cell towers, and they augment the information in the GPS in order to help narrow in first which satellites to look for, and then the satellites help you triangulate onto your location. Clearly a system. And this is not the past anymore, as many of you know, but there used to be a mobile app for GIS that Esri produced, but they've moved on to now a different paradigm for this. So now let's talk about the present. I do love this quote. Data is not information, information is not knowledge, and knowledge is not understanding, and understanding isn't wisdom. Because really what we're after here is wisdom. We want to make wise decisions. So do we really know things, and do we really understand them just because we have a bunch of data? That's the age that we live in today, I would claim. So the new paradigm for GIS that has been rolled out by Esri, and that's basically mobile platforms as well as desktops. Basically get your information anywhere you want, any way you want. Systems, cars. This is an earlier version, but basically cars today are getting built with all of these very elaborate systems in them. Basically GPS to help you locate the car, the navigation system for the car, but also radar units to tell what's around the car. I mean, cars are becoming very sophisticated, and again, FCC has mandated certain communication channels so that in the future all cars will talk to each other as a system. I don't know if that's so great or not. I don't know. What's my car going to say to your car? Move over. Now, also, if you think about all these satellites circling the Earth, how do they know where they are? Because they have to know where they are in order to do their jobs. They actually had telescopes in them, starfinders, that help them fix on celestial objects. Even though they're circling the Earth, they fix on celestial objects in order to determine where they are. And this is becoming a challenge, of course, for the microsatellites, because these telescopes are pretty big, and so they have to make them smaller to work in the small sats of the emerging world. Now, this is a representation of the connections, the internet connections, among different parts of the world. And the internet is changing how we think about geography. If you go back to Web 1.0, the early days of the internet, again, this is just in the early 1990s. And HTML pages were static. Mostly it might be IT people asking each other questions. I was absolutely shocked when I got my first advertisement sent across the internet, because I thought, oh my gosh, this is illegal. They can't advertise on the internet. This is a research network. Oh, we're kind of past that now. So then we went to the Web 2.0, communications interfaces, interactive websites, and of course now this is where machines are really starting to talk to each other, and I'm going to get to that, more of that in a moment. And all this has happened very, very quickly, just in our lifetimes. Bill Gates, back in 1995, wrote this. He's basically saying that the internet is going to change geography. That's basically what he says. Actually, what the index in his book talks about the end of geography, or the fall of geography. But actually, it's just another kind of geography. So here's a geographic sort of representation of the internet. You got things like Twitter, Skype, PayPal. This is the banking that he was talking about. WordPress, Apple. I mean, basically, this is another kind of geography that could never have existed before. It used to be you went from place to place. But when we talk about going to websites, we talk about going to a website. Have you visited Google today? Did you go to Yahoo? So this is the changing nature of geography, or one of the pieces of how geography is changing. And so GISs are also going to, and already are, thinking about or representing geography differently. This is the Internet of Things. Who has heard of the Internet of Things before? Just a few of you? Great. This is a very important concept to obtain. The Internet of Things kind of sort of sounds futuristic, but actually it's just like the microprocessor. It is everywhere today, and every one of you in this room probably. Is there anybody here who does not have a cell phone? Anybody does not have a cell phone? Good for you, because basically you're off the grid like Reg Blank from Max Headroom, which I love, because the cell phones, they control your life. They can be a problem. But anyway, if you have a cell phone, you participate in the Internet of Things, because your cell phone is connected to all the other cell phones in the world, and it knows where it is. It has a GPS. It talks to you. You can interact with it. You can get on the Internet. It has sensors. It has vibration sensors, temperature sensors, shock sensors, all kinds of things. Who here has a Nest thermostat in their home? Anybody? Nobody with a Nest, but you guys know what that is. This is a thermostat that it's a really smart thermostat. You control the temperature just as you feel comfortable, and it remembers that, and it starts to plan future temperatures based on your past preferences. It's part of the Internet of Things. So everything from connected cars that we just talked about to connected homes that I just mentioned, connected cities. I didn't see lots and lots of traffic cameras around here, but I'm sure you've got them. In the D.C. area where I'm from, their traffic cameras are everywhere. They're all connected. This is the Internet of Things. It's not some future thing going to happen. It's already here today. So it's a paradigm that's important to understand. But if you're somebody from ASPRS, it's a paradigm that's great because all these things exist physically somewhere, and they have sensors, and a lot of these sensors actually are imaging sensors, and yeah, they can lead to an image. So basically, this is what members at ASPRS do. So for me, the Internet of Things is an exciting development. It's also exciting for GIS, I believe, because GIS is really at the center of all this. If you compare all these different measurements that we can take, and this is really the age of big data, because in the Internet of Things, with not like, you know, there are just a few billion people on the planet. I say just a few billion, but there are trillions of things in the world, and there are more things connected on the internet than there are people. So all of them provide data. They don't necessarily provide information, knowledge, but they provide data. All that can be manipulated within a GIS in principle. So this is a representation of the internet and all of the connections. It's starting to look like a human brain in some ways. Scary. All right, so this is also the age of system of systems. Not just a system, but systems of systems. So we have, for example, the global food system, or the global water system, or the global energy system. And notice these things are all interlinked together. Food, water, energy, shelter, security, all these things are linked together. So they're all things that are manageable within this rubric of GIS. And security of that system, of that GIS, or that Internet of Things, or that geospatial big data is also an important piece that's going to become increasingly important as time goes by. You know, probably the people have already heard about attacks on the power grid, or how susceptible the power grid is to an outage, and cyber hacking. Well, I mean, this is real stuff, because these things, like suppose you cyber hack a car. There was an article in Wired magazine here a few months ago. They intentionally cyber hacked the car. Guy's driving down the road 70 miles an hour, all of a sudden steering wheel doesn't respond. Gas pedal doesn't respond. Brakes don't respond. Car got hacked. It was part of a plan, so he didn't freak out too much, but it's scary stuff. So we need a plan for this. All right, now I'm going to step into the future. Whoa, sorry. And I love this quote, I really do. It's about your students, and especially the young students. If you want to know how the world's going to be, it's not just the technology that we develop, it's how we as people respond to that technology, how we employ it. And most technologies, when they're invented for one thing, ended up being used for something else that we did not imagine. But the kindergartners, they're pretty good notion of what things are going to be like. So if you have kids and kindergartners, make sure they grow up to be moral people. Because the technologies that I'm about to talk about have huge, huge implications for the future of humanity. So we want moral people making these decisions. All right, so in the not too distant future, we have the globe in 3D. This actually is a real representation of a city. There are cities like Rio de Janeiro, Washington, D.C., London, major cities which have been digitized in 3 dimensions, the buildings anyway, to the level of 1 meter of accuracy. And you can go out there with GPS, not with the GPS, sorry, with survey instruments, and go survey these 3D worlds or these 3D cities, and they're actually correct. They're correctly done. So with just a few meters, like 3-meter accuracy or even better. So with the whole world digitized, and notice this is 3D. So as I said before, GIS is going 3D. It has to, because our world is 3D. Back to the UASs that I mentioned earlier. These are now something that people are actively using to make maps of the world to convey information. And if you've ever programmed one of these UASs, you'll understand that actually you can use a GIS-like interface, or literally a GIS interface, in order to program your flight paths. And what isn't happening yet, as far as I know, but will soon, is these UASs will actually produce, in the future, I believe, polygons and other features, and will actually do analytics and provide them directly to you in your handheld device in the field as you do your collection, or even in your customer's office as you're collecting the data in the field. But the fun stuff I want to talk about for the future of GIS is also really scary stuff, and this is where my talk's going to start to get pretty weird. Who has heard of the singularity of Ray Kurzweil? Anyone? Yeah, a couple of you, yeah. Pretty scary stuff. It's man and machine becoming one, more or less. The notion is this: if you look at over time, since 1900 out through today, and if we look at the graph then of computing power versus time, note that this is an exponential axis. What's happening is, over time, that computing power is increasing, continues to increase over a long period of time exponentially, such that, and here's the interesting part, on the right side we've got various brains of different things, like an amoeba, a worm, spider, lizard. Well, we're up there now, society, is up there now where the computing power of a single machine or system of machines is approximating that of a mouse. And so if you follow the projection, at some point we'll be getting to monkeys and humans, at least if you follow this projection. So this is a whole new twist on artificial intelligence. And in fact, there's a field of, new field of AI called cognitive computing, which is based on neuroscience and supercomputing and nanoscale electronics. The notion is that you can reverse engineer the brain. And ask yourself, is that a moral thing to do? You might agree that it's a possible thing to do, or you might disagree. You might say it's not possible. But people are really trying to do this. Google Glass. Has anybody gotten to play with Google Glass? This big fad came, went. I think it'll probably come back. But Google Glass, let you see. It's external. You put on your glasses. The information comes right to your eye. I happen to have glasses. A number of you have glasses. It's not a big deal for us to put on a pair of glasses, right? So, who has contacts here? Anybody have contacts? You don't have to raise your hand, but contacts. What's happened is we've taken glasses and we've embedded them in the eye with contacts. What happens if you take Google Glass and embed it in the eye? It's certainly technically feasible to think about that. Or my cell phone has become an extension of my memory. I can also talk with it, or I can take out my Bluetooth device, which I just stick in my ear. It's not very big. But in principle, this thing could actually be implanted in my ear. Could do that. People already have hearing aids that are implanted. So this is what I'm talking about. What potentially is the convergence of man and machine. It's a natural fit, actually. It's a little bit scary. Here's Google Glass used for a geographic purpose. This is a kind of a cool game. You put on these glasses. There's a software app. And as you look up at the sky, it shows you a picture of the constellation that you're looking at. But this is what we're talking about. That's why it's a scary topic. It's a scary topic. And for some people, it's a very seductive topic. And as an educator, many of you are educators, you know about the current controversy about performance-enhancing drugs, not in athletes, but in students, to improve their cognition. The temptation here is to enhance the human being with body parts and brain parts that make us smarter and stronger. And that's why we need to raise moral kids. But this is the ultimate system, the Borg. They really are. Scary stuff to think about. So, the original GIS, but transformed. That's one version of the future. I'm not advocating for this at all. I'm not even saying this is anything near term. If you want to know about the near-term future of GIS, my colleague Vince Donato is going to talk about that this afternoon, and I think it'll be much more practical than what I'm talking about. But just think about these things, because they are coming, and decisions we make today will have an impact on the future 100 years from now. It's time for a little humor. This is really, yeah, let's lighten it up. You still don't know where you are with these things. I mean, it's a big mistake following your GIS, your nav system in your car. Oh my goodness. All right, so now let me finish up with some slides about a holistic vision for GIS. This is also a holistic vision for my organization, ASPRS, and what we're interested in being involved in. And I think this is something that all of us could be involved in. So the core notion here is we want to address basic human needs. We want to do that with all kinds of data and with unrestricted points of view. All of these things can be incorporated within a modern definition of GIS as well as future definitions that Vince is going to talk about. Is that right? Would you agree? Yeah. Basic human needs, what are they? I mean, these are really simple. We have to eat. We need water. We've got to drink. We need shelter from the elements. And we need energy, because the energy systems are what we use to build, to get our water, to get our food. All these things are interrelated. It's these systems of systems. But these are the application areas that are fundamental to human existence. So if you want to make a difference, these are the places to look. All kinds of data. So at ASPRS, to us, the world is the electromagnetic spectrum. So that's everything, and potential fields, I should add as well. So that's everything from gravity and potential fields to the visible light in pictures to frequencies that we can't see, that we can only feel, like thermal, to things like radar. Basically, all kinds of data. And then we'll extend that even into social media data. So what exists on the internet? What kinds of data do humans collect? What kinds of data, it could be language, it could be location, all these sorts of things are within the realm of possibility. And when it comes to sensors, there are a couple kinds of sensors. There are passive sensors and active sensors, and the way to think of this is if I take a photograph, that's a passive sensor, but if you use flash photography, it becomes active. And that's pretty much true for most of these frequencies that you can either collect information passively or actively. And then we'd like to be able to have unrestricted points of view. So we want to look down from space, which we currently do, using aerial systems, fly over areas like aerial photography, mobile mapping, driving down the road, collecting data, as well as plugging into all of these connected devices on the Internet of Things, which includes people too. We're all connected devices in one way or another. We tweet messages, or we send emails, or we do web searches. All of these things participate in the Internet of Things, and all of them tell us something about human beings and what we're interested in. It's the human geography. that the Internet of Things can give us access to, as well as a new kind of geography, which is the geography of things, of machines. So what's happening is a convergence. This must happen. A convergence of some of our classical kinds of data sets. So we have, in the GIS world, you know, we have our shape files and our maps and so forth. But we also have CAD drawings. We have designs, engineering designs. We have point cloud data. These are the three-dimensional kinds of data sets collected by LiDAR and photogrammetry. And then we've got the image data, things that come from satellites or cameras. So all these things together, which exist as different data paradigms, need to somehow, magically, I don't know the answer, converge into a common data paradigm, which I can't describe to you today because I don't know what that paradigm is. It hasn't been invented as far as I know. But this is what must happen and will happen. This is just inevitable. Whoever does this is going to make a lot of money. We'll become famous. So this is what I'll finish with. Come to our annual meeting in Fort Worth. It's coming up in April. I'm done. Any questions? I hope there are questions. There must be questions. Okay, I'll ask. The singularity, is that a good thing or a bad thing? Anybody want to argue it's a good thing or a bad thing? Okay, anybody believe that that's just nonsense? That's just hooey. There's no possibility of that ever happening. Anybody want to argue that? No? Okay. When? Oh, yes, sir.
I'd argue that it's a good thing because if all fields are level and you have mutually assured destruction, as it were, no one dies.
So the argument is, if all things are, the reason I'm repeating is so that they can hear on the internet. Good thing because when all things are equal, mutually assured destruction means nobody's going to do anything. Nobody's going to be destroyed. Nobody will do that. It'd just be too horrible. Okay. Anybody agree or disagree with that? Yes.
I don't know whether I agree or whether I disagree.
Not sure if you agree or disagree. Okay.
I was just going to say, and don't get me wrong, I love the human race. I think generally we're pretty good, but I think somewhere in the future there's going to be some person that's just going to take something to levels of horrible.
Okay. So you're saying, I'm sorry, I'm going to repeat. So you're basically saying that people are basically good and you love the human race, but there's going to be some aberrant personality out there that's just going to mess it up for all of us, is what you're saying. Yeah. But then maybe you would say in response to that,
Good always ultimately
Go-
triumphs over evil. I mean, you always have more people going for the common good because that's innately what humans do. We're bees in a hive. We're not just the rogue hornet, you know?
gotcha, we're bees in a hive, we're not just the rogue hornet. So the argument is that there are enough people out there who are basically good people that we're not going to let that one bad person or a few bad people dominate our future. That it?
Yep.
Okay.
I have a question.
Sir.
If you think about the difference in pace of change in machines
Yes.
and the pace of change in the term of human generation,
Yes.
how do you rectify those things? So ultimately we're going to have generations of technology inside. Generations, maybe not just one generation of technology or two, but 10.
Yeah.
One's lifetime.
Generations of technology within one's lifetime. We have that today. So that's a great point. Some people use email as a primary means of communication. Other people are still using the telephone as a primary means. And then there's a whole new generation that's primarily using social media, won't even communicate via email. And so we've got at least 3 generations in a small sense of technology operating all at the same time. And so that does create some difficulties for people communicating generally, because if I'm a telephone communicator and I phone up somebody who only communicates via Twitter, or LinkedIn or something, we're not having a conversation. And so that creates problems or generational gaps, for sure, in the social world. And then, of course, around the world, we have the same thing. So we still have people living in the Middle Ages, literally, not literally, sorry, but Middle Age paradigms of the last millennia, who are now using the most modern kinds of technology to harm people in other parts of the world. We're talking about the terrorists. So,
But doesn't that argue against the singularity?
so doesn't that argue against the singularity? No, the singularity doesn't really care about that. I don't think. I mean, I'm no expert on the singularity. So I have no idea what Ray Kurzweil would say. But, I mean, if you look at the graph, all it's saying is that computing power is increasing really rapidly. And if you look at human history, as soon as a technology is developed, somebody tends to use it. We haven't, as far as I know, developed a technology that humans haven't employed. It may be that we've decided not to employ it widely. Say, for example, the atomic bomb. It was deployed, and now humans have said, no, that was just too horrible, we're not going to do that anymore. But the atomic bomb has only been with us a few decades. Are we done with it? I don't know. I don't know. But what about GIS? What do you think? What do you think is the promise of GIS in the far future? Any thoughts on that? Nope. Vince will give us maybe some far thoughts too. I don't know,
There's going to be a few far thoughts in there.
a few far thoughts. Okay, so we'll have both near and far thoughts. I presume you're not going to the singularity, however.
No.
No, I didn't think so. Yes.
It's so rapidly developing that you're becoming more and more dependent on what's behind you to keep you going forward.
Oh, yes.
And if one single component fails, then your system falls apart.
Yes.
If you put my daughter in her car and her GPS fails, she's lost. She can't read a map.
Right. The complexity of systems dependent, I'm sorry, I'm just repeating it so that people can hear. So, right. So all these systems that we've built today are dependent on other systems and pieces from the past. Things are getting more and more complicated. At some point, if one thing breaks, nobody has any idea how to fix that or where it came from. We just expect stuff to work. More to that thought?
It's just, and people don't see that.
And people don't see that.
Redundancy, power grid for one thing.
Power grid, for example.
We had a power failure on Thanksgiving a couple years ago, and everybody just sat around and didn't know what to do.
Yes.
Talk to each other.
Talk to each other, right. Well, social skills, speaking to one another. Sir?
Well, one of the things that you're talking about is location systems.
Location systems.
But yet we're using 30-year-old technology in general in the United States for location systems that we have no plan necessarily to replace. If we lost a third of the constellation of GPS units, what would we do?
The question is, if we lost a third of the constellations in the GPS system, what would we do? Because the argument is that we're using older technology there that's not being updated. But I think actually there's a lot of work going into updating the GPS systems, and there's a lot of work going in right now. The National Geodetic Survey of NOAA does a lot of work and has plans for a nationwide network. They're actually replacing physical benchmarks now with virtual benchmarks. And it's true we're very dependent on GPS. That's true. But that system becomes more robust over time, and it's augmented in different ways.
I mean, there's a private sector there.
Private sector.
If we just look at the U.S. military who owns the satellites, on their 30-year-old technology.
Yeah. 30-year-old technology that we're all dependent on. You know, it's not just place that we get from GPSs. You know what the most important piece of data that the GPS is used for, just generally in commerce? Time, exactly. Exactly. Time. Yep. All right, I think...
One more.
Okay.
Like you haven't mentioned much about natural systems.
Natural systems, yes.
Natural systems, you know, all the geo that's part of GIS and how.
Right.
So it's almost like the GIS is the link between the human machine and our natural world.
It is. So the comment is that the GIS is like the link between the human machine and the natural world. And absolutely. I completely agree. I did not talk about the natural systems today. I just talked about the machine systems because I was really trying to talk about, GIS. But what do we use GIS for, and what was the origin? Why was GIS, I go way back here. You know, what were they trying to do there in the first place? And it was exactly that. It was basically to represent natural systems. And there's a whole field, obviously, I'm sure you know about this, ecology. And systems are a big part of ecology. Just a whole other topic, didn't too much to go into. Would you have a punchline for that, though, that you'd like to end with? Because I think that's a great place to end with GIS, is how it is used to represent natural systems and help us interact with them and make decisions about them.
Yeah, just say, I like humans as a part of the natural system, not, you know, rather than the technology.
Humans as a part of the natural system as opposed to the technology. Yeah. Yeah, well, we absolutely are part of the natural system, no question. Well, actually, there is a question. Some people say, yeah, we're part of the natural system, but then there's the notion of artifact, which is human-generated. So the notion that humans are not part of a natural system, that we're something other than a natural system. And those two concepts have really are fighting it out, I think. Yeah. All right. Thank you very much for the opportunity to share some ideas with you and actually to have a little bit of a conversation. I appreciate that. I think I'm out of time. So what is next?
What is next is we will be transitioning back to the Midtown building, and at 11:30 the next sessions will begin. You have approximately 7 or 8 different sections to choose from at 11:30. After that session is over, you can go get lunch or go to the exhibit hall for our exhibitor lightning talks. So the rest of the day, with the exception of the 2:30 keynote, will be over in the Midtown building. Okay, and please join me in thanking Michael for his wonderful talk. A very wonderful way of bringing us into GIS Day. Yes.
Good morning, everyone, and thank you for that. I was able to catch the end of your presentation. My name is John Sigilski. I'm known as Ski, the president of the college, and I want to thank all of you for being here. You know, in 2009, when Nicole started this, it really was to build the geoscience awareness in the Commonwealth. And I really have to say that having been here now 4 years, it is amazing to see how this has continued to grow. So Nicole, I want to thank you for the effort that you have put in to making more of us aware of geoscience and its impact in our classrooms. I will say Nicole sent out an email recently to faculty throughout the college, English, humanities, you name it, saying, you know, there's a role for geoscience in each and every one of your classes. So we may be able to see some of our colleagues here today. I just left the General Assembly, that's why I was late, so I apologize for not welcoming you and honoring you. Thank you for being here today. Really appreciate that.
Thank you.
The General Assembly, as many of you know, is trying to work out a budget. And more importantly, for us, we're trying to worry about our education budget. And so this morning I was called at 6:30 to be there, being told that I would be able to present to a committee, educational committee, and it didn't happen until 9:45. So that's why I apologize for not being here. But I do want to welcome you to the college. As you may know, Houck is the largest, oldest, and of course, finest community college in the Commonwealth of Pennsylvania. And we definitely want to welcome all of you. We look forward to the afternoon, and I'll look forward to meeting many of you this afternoon while you're here. But Nicole, I'd like to thank you. And did you thank many on your committee as well? Already done.
You can take them as well, though.
Can I? Okay. And Nicole did give me an update on that. And so let me just call out a few people besides Nicole. Rachel Rawls, if Rachel is here, and it's hard to see with the light, wherever Rachel may be. Noel Stratton. Stuart Beatty. I don't know, anyone here? You might just want to yell since we can't see up here. Dan Egan, Megan Ferry, Bruce Field, Sarah Geddes, Maury Kelly, Zalik Patel, Mike Citino, Robin Wallace. So if any of you are here, thank you for the efforts that you put into this. And we know that there will be another keynote at 2:30. Not as riveting and as insightful, but we're excited.
It'll be better. It'll be better. It's Vince.
I'm just kidding. It is Vince. I knew he was sitting here. That's why I had to say it. But again, thank you for being here. Thank you for taking the day. I'll look forward to interacting with you. And Nicole, I again want to thank you for everything. So thank you.